Hello, people. Welcome and thank you for joining us again today for another session. Today, we bring you a talk with Rafael Abuawad. He's a software developer with nearly 5 years of experience specializing in front end web application development. His journey into the world of Ethereum began in the early 2021. Since then, he has collaborated with notable companies like Avalanche, Trader Joe, and Curve to develop solutions, implement innovative ideas, and contribute to the Ethereum ecosystem. Before we start with this amazing talk, let me remind you that you have to come back to the first website that you were on to go to the next talks, and also to follow us on our social media that will be appearing here on screen. Also, send your questions and comments in the chat for the presenter to read. Without further ado, Rafael, take it all.
Thank you, Martin. Thank you. Okay, everyone. So today I'm going to be talking about the future refinements and programmable money using Vyper and the Ethereum ecosystem. Okay, so this is a brief overview of what we are going to be talking about. First, I'm going to introduce you to Vyper in case you don't know. Second of all, I'm going to uh, explain the concept of smart contracts and the financial system, something that can be really useful to reducing cost and improve efficiency in the current financial system. And lastly, I'm going to walk you through an implementation of a smart contract or or a loan using Vyper. Okay, let's begin. Introduction to Vyper. Vyper is a smart contract programming language that was initially designed by Vitalik Buterin, one of the co-founders of Ethereum. Vyper focuses on readability, efficiency, optimization, and security. And in the last few years, has gained a lot of improvements on the tooling side. So it has become a really compelling alternative to Solidity in the realm of developing smart contracts on the EVM. I'm going to go over the readability and the efficiency part while showing code so you can understand what I'm talking about. Okay, so here's a simple smart contract using Vyper. As you can see, the code is really declarative. You can understand what is going on. And that I think is a plus because when you're working on traditional software, you don't have to keep in mind that maybe someone with less experience than you is going to read the code that you're writing. Or in some cases, you don't have to worry about your code handling millions or millions of dollars. So with readability in mind, Vyper allows developers to create efficient smart contracts without sacrificing the basic building blocks or of a good programming language. As you can see on your left, we have the version defined. Currently, Vyper is at 3.0.3.9. We have a message storage variable that is size 30. One little needed trick about Vyper is that you have to define the size of a variable before you use it. That means that there isn't dynamic arrays or lists on Vyper by default. So that you can see as a pro because you have to be really mindful of your application and the resources that you're going to utilize. Because at the end of the day, those resources of computation are going to be paid by your users. So keep that in mind. As you can see, Vyper uses decorators to define the access modifiers to a function. You can see external and view that defines that the methods are externally called, and the view decorator declares that it doesn't consume any gas. Uh, The cell keyword is also really self-explanatory. You can have that is used to call to internal functions and also to call to state variables. So yeah, Vyper doesn't have inheritance by default. Something that you can see as limiting, but when you are working with really large smart contracts, having to jump between contracts to see what is going on and to understand what is happening can be a really confusing process and something that actually we don't want to do as an industry. Uh, if you're familiar with Solidity, you may be familiar that Yule is being utilized a lot while developing smart contracts. If I'm going to the previous slide, Viper doesn't allow you to do that. Doesn't allow you to go into assembly. Uh, but as you will see at the end, Viper is really optimized to face any issues that you would want to solve using Yule. So to consume other declarations and definitions, Viper utilizes interfaces. Viper has a lot of built-in interfaces to use ERC20 tokens, ERC721 tokens that you can call. As you can see on your left, that is a simple interface definition. In the interface definition, you define all the external variables and what the signature of the function is, and what the return is, and what the type of the function is. A pure function is a function that doesn't read any state and just does some computation. Okay, I'm going to dive into the concept of smart contracts in the financial system. Maybe if you have tried to get a loan or a credit card before, you may encounter that is a really tedious process. So what I'm proposing here is using Viper to simplify everything, right? You can write your contract be a smart contract instead of traditional paperwork to make processes automatic and transparent, right? Because sometimes people do not know what is going on when they sign a contract, and that is something that we need to remove from the financial system. Uh, we can also implement the smart contracts to reduce the cost of operations. That is something that is really is a multi-billion-dollar industry if you think about it, because a lot of things are, or a lot of time and a lot of resources are wasted trying to uh, make sense of paperwork. So why am I proposing Viper to be used here? I think Viper is simple, it's human readable. That means that almost anyone with a basic knowledge of programming languages can understand it. It's secure by default. You're going to see a lot of decorators that I'm going to show you that we can use to enable security at the programming level without requiring external libraries, and it's efficient. So that would reduce cost on the financial institution side. Okay, so I'm going to lay down what the smart contract for a loan is going to be. I'm going to write the smart contract using Viper. The smart contract is going to have these local variables, state variables. We have a lender that is going to be maybe the address of the bank. It's not necessarily a bank, but we are going to use that for this example. The borrower, the asset that we are going to lend, that is going to be represented as an ERC20 token. The interest of the loan, the total amount borrowed, the total amount paid, the payment counter to track the amounts of the count of payments that the borrower is going to be making throughout the process, and the payments. Uh, that is going to be an array, and we're going to see a lot of cool concepts of that using Viper. Okay, let's begin. So we're going to define first the state variables. As you can see on your left, we have the lender, that is a public variable with an immutable modifier that is wrap an address, that is wrapping an address. So what does that mean? That means that the lender address is public, and once defined at the construction of the smart contract, uh, one can't be changed. So that is an interesting thing that you know, in the Ethereum ecosystem and in blockchain at large, immutability is a really useful concept, and that is something that we can do with Vyper seamlessly. So we can see at the end the payments. That is a dynamic array. As you can see, we define the type, and also we define the size with the 60. So that is a 5-year loan, and the other variables. So yeah, we have the version of the smart contract, and we're importing an interface. So that's really cool. We define the constructor and provide the lender, the borrower, the asset. All of that are immutable variables, immutable state variables, and we also define the interest that is immutable, so we can change it later. We have an internal function that calculates the payment that is going to be made by the borrower each time that he or she wants to pay. We have a bunch of external methods to interact with the smart contract. We have a fund method that allows the lender to transfer a specific amount of funds to the borrower. It verifies a lot of things, and as you can see, it's really readable. So that would uh, avoid any misconceptions during the the interaction between the borrower and the lender. We have the pay method that allows the borrower to pay the lender, and this also registers the payments. As you can see here at the middle, when you add a payment, it gets registered. It also verifies that we don't overpay the loan. Also that sorry, that we are the borrower. As you can see, we have this global variable called MSG, that stands for message, and dot sender, that access the address of the individual that is calling the function. So as you can see, comparing Vyper with Solidity, Vyper is a lot more readable. We have a pay principal method to allow the borrower to pay directly to the principal of the loan without paying any interest. We have a set interest method to allow the lender to define the interest, maybe something that needs to be variable. In some cases, a lot of loans change over time, and in this smart contract, we can do that. So that's really useful. Also, we can see here the MSG.sender again, and the assert keyword. Sorry, I didn't explain that, but the assert keyword is like a require that asserts that the condition is being met. If not, the method reverts. So that's really useful. So yeah, I'm going to be briefly go rewind and go again on all these methods. We have the fund, the pay principal, and the set interest. So it's really simple, and we can avoid a lot of confusions while developing, while interacting with a financial institution per se, or if we want to, I don't know, create some decentralized protocol. As you can see, Vyper is really readable, so you can, even if you don't know anything about smart contract programming, you can understand what is going on. So I think plus and something that is going to be really important in the future. Okay, so my conclusion is that Vyper provides readability and security at programming. Let me go over that security part. As you can see here, the decorator non-reentrant. In other smart contract programming languages, we don't have these baked in into the language, but in Vyper we do. This allows the method to be secure to reentrancy attacks by default, right? Because you can define it at the compiler time, and that's really, really useful. Uh, I don't know if you are aware that a lot of hacks in the industry are reentrancy attacks, and this allows us to develop smart contracts and decentralized applications uh, with security in mind and at the programming language level. So that's really, really useful. Okay, so to end this, I'm going to be going to through what I just said. Vyper is a secure and readable programming language, but how really readable is it, right? Recently, OpenSea created a new protocol called Seaport to enable the transfer of NFTs as an NFT marketplace. And they rewrote one part of the token transfer using YOL with Solidity, and actually a reimplementation of it in Vyper that used like 3 lines of code was faster than a 100 line of code file. So yeah, that's going to give you an idea of how powerful it is. There is a lot of talented people working on the project. There is a lot of tooling, and uh, we we can create financial tools even in the current system that could leverage the power of programmability. Uh, Even if you're a beginner, you can understand what is going on. Even if you don't know how to code, you can understand what is going on and what maybe the application or the program is doing. So I think that's going to be really useful. So uh, without further notes, I would like to invite you to maybe dive into Vyper, use create something. Maybe you can try Apex or Brownie to develop your applications and see what you can do. I think that the most important thing is uh, uh, do a hands dive and start creating applications. So thank you everyone, and hopefully I can answer all of your questions.
Thank you, Rafa, for your presentation here and for sharing with us all this great information. Remember, two things. First is that you have to come back to the first website that you saw that you were on, and so you can go to the next presentations. And also that the chat box is open for everyone that has some questions and comments for Rafael. And well, without further ado, thank you so much, people. Thank you so much, Rafael, for this amazing presentation, and hope to see you very, very soon again.
Thank you, Martin. Have a nice day. Take care, everyone.